And welcome to video 4 part 2. So it's just an extension on integration. So integration itself, just being able to integrate things, was in our part 1 video, but I'm extending more into integration now, and we're looking at integrating in terms of area, volumes, and approximations of areas. So another very important thing in every single HSC, they love asking area and volume questions. And it's just being able to integrate really and understand how to go about integrating them. So what I've created here is a summary on all the different types of areas that you can get given. You've got just basic areas, areas that are below the x-axis, areas above and below, area between two curves, which is a very common one, and then the split method, which I've just named it the split method, not as common. Okay, so then after that, we're going to go on to some volume questions, both around the x and the y-axis, and finish off with just my version of how to do trapezoidal and Simpson's rules. So this is all I kind of branched under the integration topic, okay? Like I said, very important. So to find the area underneath a curve, you just integrate, okay? As long as they give you the function and some bounds, it's really straightforward. The first one here, just to find the area. Now I've just done some example questions here. I've just made these numbers up, these curves up, just to give us an idea of what it's going to look like. So it's important in your HSC, I call it the line, that first line the marker wants to see. That's going to give you the mark. The fact that if they asked you to find the area under the curve y equals x squared between the values 3 and 1, the first line, the line the marker wants to see, is that you know it's the integral of x squared with respect to x between the values of 3 and 1. And there's a mark straight away. So now it's just a matter of integrating, okay? So add 1 to the power and divide by it. And it's a definite integral, so subbing in my values. Subbing in my values, showing that line of substitution, and getting your answer. Something like that is very straightforward, not asked so much in HSCs just because of how basic it is. However, it would be at least out of 2 marks. You'd get a mark for knowing it's an integral, and then getting a mark for knowing your integration of a definite integral. Okay, so moving on to now areas above and below. So in green, you'll notice I have written a little summary of what to do. I said absolute value the integral. So basically areas underneath the x-axis are going to give you a negative area. So it's just about knowing, showing the marker that line of working, that you know that it's going to be the integral of your function with respect to x between 6 and 0, and I'm going to take the absolute value of it. So subbing in my bounds, taking the absolute value, I get my answer of 324 units squared. So I get that negative value. One thing I have seen people do before is to eliminate the absolute values, you can just do a negative at the front. So take the negative version of whatever it is. And then that's just going to make a double negative eventually, which gives you the positive. So that is another way of doing it. Otherwise, the absolute values are also fine. Okay, next is when we have both areas above and below. So it's integrating both of the last 2 things into one type of question. So when we have to do this, I have said we split the integral up and you absolute value the negative part. So once again, show the marker you know this. Be very clear, be explicit to get that line of what the marker wants to see. So show them that you know you're going to have to do the integral between -1 and 0 of this function with respect to x, and it's below the axis. So I'm going to have to take the absolute value of it, and then I'm going to add it with, so put area equals, the integral between, let's say, 4 and 0 of the function, and that will give you my area. There's your line of working. The marker wants to see that line, that you know what you're doing. So subbing in my values and simplifying, again, integrating, add 1 to the power and divide by it, or think of it as add 1 to the power and times by 1 over by it, which gives me my quarter at the front. And I've written that step there so you can just see how I'm getting the 1 over 8. And then simplifying things from there. Don't forget about your absolute values. It's an important part of these questions. Now, one important thing here I want to talk about when you get this answer here is the difference between an integral and the area of something. There is a slight difference, okay? I know that to find the area you do the integral, but there is a slight difference that the HSC loves testing people's knowledge about. So I'm just going to make a little side note over here. If a question asked you to find the integral between 4 and -1 of this function, it mentioned nothing to do with area, it just wants the integral. What you would get is this. But when it asks you for the area, what you get is 32 1/8. Think about that for a second. Think about why that would be. What's happened there? Why did I get, or how did I know it was 31 7/8? Hopefully you've realized is what that integral didn't do is take into the consideration about that negative area. So it didn't absolute value the -1/8. So the point is that when you take just the integral, it subtracts off that negative area from your answer. It doesn't take the absolute value of it. So in a HSC, if they asked you to evaluate that integral, the answer is 31 7/8. That's what they're looking for, and that's the correct answer. But if they ask you for the area under that curve between 4 and -1, your answer is 32 1/8. Notice the difference there, as opposed to an integral and an area question. They do like to play on that quite a bit. Okay, moving on. This is the most... So what I have said there in the green is you take the integral of the top curve and you subtract the integral of the bottom curve. Why that is because if you just ignore the straight line y equals 2x here, if I had to do the integral of that area, I could do the integral between these two values and it would find that entire part in here. Then I could do the integral between these two values of that straight line and it would find the area just under here. Subtracting that off, I would be left with the shaded region. So that is why we subtract them. So once again, you show the marker you know this. Give them that line of working that will get you the mark. It's always the one that's sitting on top that goes first. So the integral of -x lots of x minus 4, and you're going to subtract the integral of 2x. That's the line that will give you the mark. The next thing is working out your bounds. Thinking about what are those bounds there that you're integrating between. And it's always, always, always your points of intersection. So we can see straight away here that it's between 0 and something. To find those points of intersection, we solve them simultaneously. So putting them equal to each other because they're both equal to y. Solving simultaneously, I get that my x-intercepts, the x values of the points of intersections are 0 and 2, which makes sense, which means this value here is 2, so I'm integrating between 2 and 0. Now, one thing that I'm going to do, because I'm integrating, I'm going to expand this bracket out here, just to make my life easier. Now I have two separate terms, which I know how to integrate easily. Another important thing that you can do here, you don't have to, but you can, and it often saves you quite a bit of time. If, and only if, your integrals have the same numbers on the bounds, you can put them together. So see how they're both between 2 and 0. So I can actually write this as just one big integral between 2 and 0. Don't forget the negatives there though, minus 2x. And clean it up, and then I only have to do one integral as opposed to two separate integrals. Okay, so now I'm just going to integrate. So what I have done now, going back, is I expanded these brackets here. I expanded them because I know I'm integrating and I need them as separate terms to be able to integrate. Once I've expanded, I realized I have the same numbers on both of my bounds. If and only if you have the same numbers on both of your bounds, you can put that together as one big integral. Just be mindful of that negative here, okay? So I'm going to have it as one big integral as negative x squared plus 4x minus 2x in terms of x. And it saves a bit of time having just one integral instead of two. Then, gathering like terms and cleaning it up a little bit, you can simplify to just negative x squared plus 2x. And there's my solution written there, subbing everything in. Don't forget, the end of this, we are doing areas, so you need units squared on them. The last method is the split method. Not common and often is the most trickier one for people to see, but I have seen it asked in HSC. So, thinking about this, it is confusing because a lot of people think it's the area between two curves, and they do what we just did on the left. Notice it's the exact same graphs, exact same functions there, but I've just shaded a separate part of the graphs now. So a separate region. So this time, taking the area under the top curve and subtracting the area under the bottom curve isn't going to give me that shaded region. This time, what is going to give me that shaded region is if I take the area underneath my straight line here between 0 and what I know that to be is 2, that will give me this part in here. Then I take the area under my curve, my parabola, between this value and this value, which would be my x-intercept, which I can see straight away is a 4. And that would find me this part here. And I would just add them together. So I'm going to write that line the marker wants to see to give me my mark. It's the integral of my straight line between 2 and 0 with respect to x. And I'm going to add that with my integral between 4 and 2 of my curve. I'm just expanding it with respect to x. Now they don't have the same bounds, so I can't put them together. I have to do them as two separate ones. So I'm going to go ahead and do that. Okay, I haven't double checked that working, but hopefully there are no errors there. Subbing it all in off the top of my head, you should end up with 44 on 3 if I've done those calculations in my head correctly. So that's your split method, where you have to do it in a split version because you can't just do the area between them. That there is all of your types of areas now summarized into those 5 main parts. So it's about being able to look at the function and see straight away, this is what I need to do. Know those green parts that I've written there in brackets very well. All right, next, very important and always asked in HSC is volume. So it's where a curve is rotated around a certain axis, X or Y. Now, in extension 2, you look at the curve being rotated around another line. But for now, in advance, we just look at the axes. So I've written there in the green the formulas. You need to know these formulas and be able to write them off the top of your head. To remember which one's which, when you are integrating around or finding the volume of a curve bounded by your x-axis, it's v equals pi outside of the integral between b and a of y squared dx. When you are integrating around the y-axis, it's v outside of pi, lots of b on b and a, x squared dy. How I taught my students to remember this is when it's rotated around the x-axis, you want dx because it's around dx axis. So when it's around dy axis, you want dy. Then it's just the opposite letter being squared on each one. So remember that. So the first thing the marker will want to see is that you know the formula and which one to use. So write it out. We need to find, in this question, the volume of e to the x plus 1 rotated around the x-axis. So what that means is it's going to look something like this. That's the three-dimensional shape that we're finding. One thing I haven't given you in this question, which they need to give you, is a point on the x-axis that we're going to. So let's say between 0 and, let's go 6. Okay, now we're going to, step 2, find what y squared is that we need to sub in. So if y equals e to the x plus 1, we need y squared. This is where your mark comes from to start with. So y squared is going to be y squared. So e to the x plus 1 all squared. Now my biggest tip to you is to expand something like this if you can. If it's not too much work, expand it. It's going to make your life easier when you come to integrating it. Now take your time. Don't make a silly mistake here. E to the x times by e to the x. I plus my powers, so I'm going to get e to the 2x's. So now I have a value for y squared. There's a mark. Now I sub it in with my bound. Now I just integrate and sub in. Integrating exponentials was in last video. Differentiate the power and divide by it. Big thing to remember when you are dealing with exponentials in your definite integral, subbing in 0 isn't going to just make everything fall down to 0, because anything to the power of 0 is 1. So be careful of that. Now something like this, they're most likely going to tell you to round to your answer to so many decimal places. So you would just throw that in your calculator, just because it doesn't clean up very nicely. Now, one thing I have forgotten, which is a good lesson, because I always did it at school, and it's such a silly mistake to make, is timesing everything by pi. Okay, so, and don't forget your answers in units cubed. So bring that pi down. It's fine to leave it in terms of pi if you want to. Otherwise, if it's to decimal places, you times your pi in. All right, now let's look at one rotated around the y-axis. So we need dy. So again, step 1, write your formula out for the marker to see that you know what you're doing. Step 2 is now find x squared. Sometimes this can be the hardest part, finding your value squared that you need. So I have y equals 8 log x minus 1. I need to rearrange that to somehow get x equals and then x squared equals. So I'm just going to rewrite it like this for a second. Now I'm not a big log e person, I like ln, but in this case I'm going to write it as log e because I'm going to take my 8 over and write it in this form. Now this is in log form. I'm going to undo this log because I want x, so I need to undo the log. How do you undo a log? You write it in exponential form. So hopefully your teacher has taught you in some way, but I find that the way I think of it is it's this number down here to the power of this is equal to this, and that's how we undo a log. So I'm going to get e to the power of y on 8 is equal to x minus 1. So e to the power of y on 8 plus 1 is equal to x. So now I have x, I need x squared, so squaring it. And this is, once again, very similar to the last question, expand it. So once I've expanded it, knowing my indices laws well is important there, subbing it in and cleaning it up. Now it's between 6 and 0. No, don't make the mistake and do between 2 and 0. 6 and 0 because we're on the y-axis, so we need y values. Okay, and so now I'm just going to integrate and sub it in. And once again, something like that doesn't clean up that nicely, so putting into your calculator could be the best way to go. You could possibly go one more step and say these are like terms, so I could have 20 e to the 6 on 8 or 3 on 4. And I'm going to have 6 minus 20, so minus 14 units cubed. But otherwise, calculator's fine for that. And last of all is finding areas by approximations. You have two rules, the trapezoidal and Simpson's rule. Now, you get given these formulas on your reference sheet. However, the formulas I use or have adapted, they're slightly different to the ones on the reference sheet. So, I mean, if you have your own formulas and you like those, stick with those. Otherwise, if you've always found it a bit tough or a bit confusing, perhaps this is the better way to look at it, because I find this way is quite straightforward and not as confusing in my opinion. So let's look at trapezoidal rule to start with. We have to find the area under this curve using 5 function values between x equals 1 and 3. Now this curve, I do know what it looks like, so it's not going to be hard to just quickly think about this graph. So I'm going to have the cubic, and it's only between 1 and 3. And cubic subtracted by 1, this is going to give me something looking like this. It goes through 1, so it's not the best. Goes through 1 here, so 3 is about here. So I'm finding the area under here between those two values. Now, what I have here are my two formulas. H on 2, f of a plus 2f of b plus f of c. Now, if there's more than 3 values I need to sub in, then I go to the green formula. H on 2 f of a plus 2 f of all the middles plus f of c. So yellow formula for 3 values, green formula for more than 3. Now, the next thing I think about is, okay, they want 5 function values. So they want 5 values. So immediately I'm using my green formula here. And I need to think about what these values are. If I don't have the graph there, I just draw a little number line, okay? I've got between 1 and 3, and I need 5 numbers. So there's 2 numbers so far. Think, okay, well, halfway between them is 2. That would be the values I'd use if they asked for 3 function values, but they want 5, so I need to have 1 more in here and here, which gives me 1.5 and 2.5. They're now my values of A, B, C, D, and E. Now I'm going to use my formula, sub it in. H is always just whatever each value here is going up by. Okay, so using that idea, H is 0.5, so I have a half as H. It's divided by 2 because it's divided by 2. Then I'm going to show the mark of this line, f of 1 plus 2 lots of f of 1.5 plus f of 2 plus f of 2.5, then f of 3 on its own. That there gives you a mark, at least a mark, depending on this type of question. So now you're actually not, even though it's an area formula, you're not actually ever integrating in trapezoidal and Simpson's rules. If you go to integrate something, you're not doing it correctly. You don't have to integrate. That's what the formula does for you. It does all of that part. So now cleaning it up, I'm using my approximately equals to because that's what trapezoidal and Simpson's rules do. They're approximates. So I get a quarter, and now f of 1 just means sub 1 in where x is to my formula. So I'm going to have 1 minus 1 gives me 0, plus 2 lots of sub 1.5 in there. When I sub 1.5 in there, I'm going to have 3 on 2 cubed, which is going to give me 27 on 8, minusing 1. F of 2 in there. So skipping ahead a little bit, without my calculator, I get these values. Now, just throw it in your calculator and you'll get your answer. And hopefully, if all my calculations are correct, I get 12.5 or 25 on 2 units squared. And there it is. So let's break it down again. We just have to, you don't have to draw the curve, you just have to draw a number line. All right? Find what your values are going to be, depending on how many function values they want and what values you're in between. The distance between each one of those values is your height. Then you're subbing each one of those values into your original function. Don't forget to times the middle terms by 2. And lastly is our Simpson's rule. Exactly the same process, but this time we have h on 3 outside of f of a plus 4 f of b plus f of c. Now that's if you have 3 function values. If you have more than 3 function values, so if you have 5 function values, it's not like the trapezoidal rule where you have 1, 4 times all the middles and then 1 on the end. It actually has a different type of pattern. It's 1, 4, 2, 4, 1. So I tell my students a lot of the time to just remember that little pattern of numbers. So for instance, on my trapezoidal rule, I just think trapezoidal rule is 1, 2, 1. Or if there's more values, 1, 2, 2, 2, 1. Or 1, 2, 2, 2, 2, 1. You're timesing all the middle terms by 2 and the outside terms by 1. However, Simpson's rule, if there's only 3 values, it's 1, 4, 1. But if there's any more than that, it's 1, 4, 2, 4, 1. So remember that pattern. If in the rare case there's even more than that, it would be 1, 4, 2, 4, 2, 4, 1. So remembering that. And if you can't see what I'm talking about, this is what you're multiplying your f of out the front. So notice where those numbers are coming from now. But that's just a little trick on how I remember the formulas for your Simpsons and trapezoidal rule. Okay, so this question here in particular, it wants one application, which just means one set of values, which is going to use this formula here. I'm still going to do my number line. I've got between 2 and 6, and I only need 3 numbers because that's what one application is, 3 values. So I just need the one in between it, which is a 4. So I'm going to say to myself, okay, I'm going to, in my HC, I would write out my formula. It's written right there though. My height is the distance between each one, which is 2 on 3 this time, and show the mark of this line. Okay, always show that line. Then just subbing those values into your original function. I get the log of 2 minus 1 is 1, plus 4 lots of the log of 3, plus the log of 5. Now, log of 1 is 0, so it's 2 on 3, and then I'm going to have, if I think about my log laws, it's going to be the same thing as the log of log of 81. What is going on here? The log of 81. Plussing means I times by 5. But again, put it all in your calculator and you get your value. So there's the end of that video. I hope you enjoyed. Don't forget to subscribe.